Page 124, lesson 2.7 is on solving proportions. So we've talked about proportions before. So like the book says here, basically a proportion is an equation that states two ratios are equal. So an example, we could have 1/3 equals 2/6. The book gives an example with letters, sometimes with numbers. Maybe it's more easy for you to understand what's going on. So if you look at problem 1, what we're doing there, instead of everything being given, we are trying to solve the proportion. And that's mainly what we're going to be looking at in this lesson, is not seeing if stuff is proportional, but figuring out if there's a variable or even a couple of variables in a proportion, what value would the variable have to be in order for those fractions, ratios to be equal. So if you look on problem 1, we've got 7/8 equals m over 12. So if we're solving this, we could just use the multiplication property like the book mentions. So we could just say m is being divided by 12, so let's multiply by 12 on both sides. When you do that, that's like 12 over 1. And then if you multiply, you get 84 over 8, and then divide that is 10 5/10 or 10 1/2. Another way we've talked about doing these, especially if you have a calculator, if you wanted to, you could try to find a pattern going across or up and down, going towards the variable, multiplying or dividing. So I could go this direction, for example, and I could say, how can I get from 8 to 12? So if you did on your calculator, if you took 12 divided by 8, and you get 1.5. We know going from 8 to 12, it's either multiplying by 1.5 or it's dividing by 1.5. Well, it's getting bigger, so we'd be multiplying by 1.5. And then if you take 7 times 1.5 would be 10.5. So that'd be a different approach. Again, if I don't have a calculator, probably just going to do what the book does. But if you do have a calculator, that's another option for you to consider. So the guide at 1, they're asking us what the solution for this equation is. If I'm trying to find a pattern here, I don't find a real nice, easy pattern going from 5 to 7 or from 5 to 4, going towards the variable, multiplying or dividing. What we can do is just go back to what we did when we solved equations. We can just say the variable is being divided by 7, so we can multiply by 7 on both sides. That's like 7 over 1. And so that would be 28/5. That's reduced, so you can leave it like that if you want. Otherwise, you can change it to a mixed number as 5 3/5. As always with any equation where you have a variable, you can substitute your answer back into the equation to make sure that it works. In this case, what I would suggest maybe would be easiest if you had a calculator. 5 3/5 would be 5 6/10, 5.6. So you could do 5.6 divided by 7, and you could do 4 divided by 5, and both of those you should get 8/10. The next thing the book talks about is cross products, or sometimes they call cross multiplication. This is going to be kind of my last resort. Like if nothing else works, I will do this. Sometimes we need to do it this way. Usually what I'm going to do is, very first thing is I'm going to be looking for patterns. So we can look for patterns, multiplying or dividing, going toward the variable. If that doesn't work, like we did on that last problem, if they're just dividing, I'm just going to multiply by what it is they're dividing by. If it comes to it, then I will do cross multiplication or cross products. Cross products, basically, just to kind of explain what they're showing in the example in your book. They have 3/4 equals 9/12, and they're explaining to you that cross products on a proportion are equal. Basically, the way cross products work is it just happens to work, kind of. But I don't want you to think it's some magic trick that we're doing here. Cross products, basically what we're doing, it's not going to look like this at all, but it's basically, let's take the two denominators and multiply them together. So 4 times 12 is 48. And then it's like saying, I'm going to multiply by 48 on both sides of the equation to clear out my fractions. So multiply by 48 here, multiply by 48 here. As long as I'm doing the same thing on both sides of my equation, then I keep it balanced. Okay, at this point, you're saying this looks nothing like what the book's saying about cross products. What we can do here, though, is we're multiplying. We can reduce these both by 4. And that gives us 12 times 3. So 12 times 3, which is 36. Over here, we can reduce both of these by 12. That gives me 1 and 4. 9 times 4 is 36. And those are equal. Okay, now what somebody figured out, probably somebody being lazy trying to think of a different way of doing things where they didn't have to do as much work, they said, oh, we ended up doing 3 times 12. There's 3 times 12. We ended up doing 4 times 9. There's 4 times 9. And that's the idea of cross products. So you can just do this. You can just say, I'm going to do 4 times 9. And I'm going to do 3 times 12, and that will get you the answer. In fact, some cases when we have variables involved, we're going to have to do it that way. We're not going to have a choice as much of doing it that other way I mentioned. I mean, we can, but really it is kind of inconvenient to have to deal with all that every time. So just so you don't get confused, cross products or cross multiplication, we only do that when we have an equal sign, when we have a proportion. One fraction on each side, and these things are equal to each other. So the book kind of goes through their idea of how it works, why it works. I don't think it's as meaningful or as easy for us to understand with all the letters. That's why I just did that with numbers for you guys. Another thing besides looking for patterns, another thing I'm going to do is look for reducing. If I don't see a pattern, I'm going to see if something can reduce, and then maybe there will be a pattern as well. And then, like I said, last resort, if I have to, I'll do cross products, because really they actually create more work for you. There's an extra step. Instead of 1 step, it'll take you 2 steps if you do cross products. So if we look at problem 2, we got 4/3 equals 8 over x. I'm not going to do cross products for this because I'm going to be done by the time they get done with their first step. Going towards the variable, the numerator is twice as much, the denominator is twice as much also. 3 times 2 is 6, and I'm done. Okay, cross products, did they get 6? Yes, they did. It's just, to me, this is an easier way than doing the cross products if I don't have to. So if we look at the got it 2, they're asking for the solution for this. So again, if you want to, you can do cross products. I would say it's going to be less work for you guys if you just say they're dividing by 3. I can multiply by 3 like we did on the got it 1. But just to show you, if you wanted to, you could do this. 5 times y is 5y. 3 times 3 is 9. And then they're multiplying by 5, we can divide by 5. So y equals 9/5 or 1 4/5. Again, to me, your other option, they're dividing by 3, multiply by 3, and I get 9/5. Actually is just really 1 step instead of 2 steps. It's not a big deal, and you can always do cross multiplication. It always works, whichever way you find easier. Just to mention, if we had a little bit of a different problem, let's say we got 5/6 equals 11 over x. So a couple things. One is if I'm going from 5 to 11, or if I'm going to from 5 to 6, that's not a nice pattern. The other thing is the variable's in the denominator here. So I can't just say they're dividing by 11, I'm going to multiply by 11. In this case, it's probably just as well to go ahead and do cross products. So 5x, this is 6 times 11. If you want to write that down, you can. I'm okay with you guys going straight to that 66, but just make sure you are multiplying those numbers. And then you can divide, and this can be our answer, or we can change it to a mixed number. The other option is really the only other way that we can do that is if we flip-flop these. It's kind of like if I have proportions and I'm comparing apples and oranges, and now I say oranges and apples. If they were proportional before, if I just flip both of them, it's still going to be proportional. So in other words, I could say 6 over 5 equals x over 11. Now I could say they're dividing by 11, I'm going to multiply by 11, and I'll get the same answer. Okay, like I said though, if we have to switch it around by that point, it may be just as quick for you guys just to do the cross products. So when we get to problem 3, we really don't have much of a choice here. There's not a good pattern with 5 and 4. Also, they're now giving me 2 variables in the problem. So we could kind of do what cross products does. In other words, we could say 5 times 4 is 20. I'm going to multiply both sides by 20 to get rid of the fractions. And that's really what cross products does. The quicker way is that it ends up doing the same thing if we do this. So we're going to have 4 times b minus 8, and we're going to have 5 times b plus 3, and those are equal to each other. That I would really recommend that you write it out like the book has. Don't skip that step, because distributing, sometimes people even forget things even if we have it written like that. So we're going to do 4 times b minus 4 times 8. And in fact, if you want to include that step there, you can. So that's 4b minus 32. On the other side, we're going to do 5 times b plus 5 times 3. Okay, so I would either draw the arcs as you go or write that step in between. Whatever you need to do, make sure you're distributing to everything on both sides. At that point, we have a variable on both sides of the equation. Again, our work is going to look a little different than the book. We can get rid of the one with the smaller coefficient if you like dealing with positive numbers. So we could subtract 4b on both sides. And then they're adding 15, we can subtract 15. That's 1b, that's the same as b. You can divide by 1 if you want, but it's not going to change anything. So b equals negative 47 would be our answer. So the next thing we've got is the got at 3. So they're asking the solution for this proportion. Again, we've got 2 variables here. Anytime we've got 2 variables with just a fraction on both sides, we can go ahead and cross multiply these. So make sure we distribute this. So that gets us to 6n equals 10n plus 20. At this point, we have variables on both sides of the equation. So since there's only one constant here, actually the quickest way for us to solve this would be, let's say we're just going to get the variable on the left side, keep the constant over on the right side. Normally, we would try to avoid negatives. We would have subtracted 6n, but if you subtract 6n, you're going to end up with 0 equals 4n plus 20, and then you can subtract 20, I guess, and then divide by 4. It's just more steps involved. So just because there was only one constant here, you can kind of analyze the situation and see what's going to be the quickest route for you if you want. Just like any of these problems, once you get the answer, you can put that back in the original equation to see if it works or not. So if we put a -5 in place of the n, -5 divided by 5 is -1, and then this would be -10 plus 4, which is -6, which is also -1. So that does work. Definitely we need to make sure we're doing the work and then checking our answer. It's not efficient for you guys just to be guessing numbers and be like, oh, let me try this number, to avoid working it out by hand, because, and especially too, we're going to get into more complicated stuff and you're not going to be able to just figure out the answer by trying to guess numbers. So the next part talks about real world situations and how we want to write our proportions so they have the same units. So for example, I'm just going to talk about the correct one here. 100 miles over 2 hours equals X miles over 5 hours. Notice the miles are on top on both of them, hours are on the bottom on both of them. We have to be consistent. Okay, so problem 4. A portable media player has 2 gigabytes of storage and can hold about 500 songs. A similar but larger media player has 80 gigabytes of storage. About how many songs can the larger media player hold? Okay, technically it didn't say write a proportion and solve it to work it out. So I know you guys could look at it and say, well, 2 to 80, that's 40 times as much. It's going to be 40 times as many songs. Okay, that's fine. Just to practice though, that's how they set it up. Gigabytes over songs, gigabytes over songs. And then I wouldn't do this because of that nice pattern there. I would just say let's multiply by 40 and we get 20,000. So the got it, similar situation. An 8-ounce can of orange juice contains about 97 milligrams of vitamin C. So about how many milligrams of vitamin C in a 12-ounce can of orange juice? So 8 ounces is 97 milligrams. 12 ounces is how many? Whatever variable you want to use. This one, especially if I was able to use a calculator at all, I would be trying to check for a pattern with that. And if you do that, 12 divided by 8 is 1.5. So this would be multiplying by 1.5, and then if you work that out, is 145.5 milligrams. Okay, and again, you have the cross multiplying option there if you want, or if you want to, sometimes, you know, I'll try to make my variable be in the numerator so that if I don't have a pattern, I can just multiply instead of having to cross multiply. So different ways you can work that out. So if we look at the lesson check number 3, so on 3, if we cross multiply here, so we're looking at 2 times the quantity W plus 3 is going to be equal to 4 times W. So we distribute, we get 2W plus 6 equals 4W. So we subtract 2W on both sides. And then they're multiplying by 2, we can divide by 2. So the answer would be 3. W equals 3. And again, we can substitute that in and figure out that that works. Then if we look at number 5, a band went to a recording studio and recorded 4 songs in 3 hours. About how long would it take for them to record 9 songs if they record at the same rate? Okay, this one's not as nice of a pattern. It's not just like, oh, it's 2 times as many songs. So 4 songs in 3 hours, 9 songs in how many hours? I'm just going to do H for hours. And again, put your units next to those. It's going to make it easier for you to make sure you're putting your numbers in the right spots. If you just put numbers down, there's really nothing to make sure that those are in the right spots and that they're directly across from each other with the same units. So if you wanted to for this, we could try to find a pattern. So we could go from 4 to 9. If you do 9 divided by 4 is 2.25. So this is going towards the variable multiplying by 2.25. And then if you multiply that, you get 6.75 hours. The other way you could do this, you could try to go from 4 to 3. That one, if you do 4 divided by 3, you get 1.3 repeating. So that's not as nice of a pattern. I mean, I can divide 9 by 1.3 repeating, and I'll get about the same answers if I put enough 3's on my screen, but the other one was a nicer pattern. Or you can just cross multiply. Cross multiply, you got 4h equals 27 divided by 4, 27 divided by 4, and you'll get that answer. So this gives you an idea of how to solve proportions.